Hello students, in today's class we will be starting with spherical surface refraction. So, we have seen how refraction occurs at plane surfaces, then we applied that concepts in the case of prism, we understood total internal reflection. So, now how refraction occurs at a spherical surface, right. So, that is what we will be learning in this chapter. So, spherical surface refraction or refraction at spherical surfaces, clear. Okay. So, we will directly start with the derivation of the object and image scenario in the case of spherical surface refraction. So, what I am saying is, let us say we have two different media. So, on this side we have a medium of refractive index mu 1, on this side we have a medium of refractive index mu 2, right. So, let us say there is an observer who is in medium mu 2 and he is observing an object which is placed in medium 1. So, this is the object, that is the observer, right. So, we know that this interface what you see here is basically the boundary between the two media. So, this is one medium, you can consider, let us say if this is air, right, if this is air you can consider that this is a different media. So, the interface, earlier we were used to looking at interfaces as plane surfaces, right. The boundary was a plane surface, but now we are considering a boundary which is spherical. This is spherical. Once again keep in mind, this is not a two-dimensional structure, right. This is not just a line, it is like a bowl. I have told you, just like we place mirror. So, this is a boundary which is three-dimensional, clear. So, you can understand it like this. So, this is you can say a cylinder like structure from which you have removed some part of a sphere. So, something like that, clear. So, this is like a bowl in this manner. So, it is a three-dimensional structure. Okay. So, we need to understand where the image is formed according to this observer. So, if the object is placed here and this is the person who is observing, where is the location of image, clear. So, once again I have told you that we will only be considering the paraxial rays for all the calculations. So, even in this scenario also we will be considering the paraxial rays only. So, we can say that the midpoint of this boundary we can consider that as the pole, and we can say that because this interface which we have considered, the boundary is the part of a sphere. So, if I extend this further hypothetically, so it forms a sphere, right. So, the center of curvature of that would be, let us say, somewhere over here. So, let us say this is the center of curvature of this interface, clear. So, remember this is a sphere from so the interface is in the form of a part of the sphere, that is the idea basically, clear. Okay. So, now this is the center of curvature, here is the object, we need to find the location of image. Okay. So, now if I consider a light ray which is incident in this manner, so this is the incident ray. So, we know that it undergoes refraction at this surface, at this interface, and then it enters into that medium depending on whether mu 1 is greater than mu 2, I mean mu 2 is greater than mu 1 or lesser than mu 1, the light ray will bend towards the normal or away from the normal. So, we know that idea. So, for that, to understand that, we know that we need to know the normal at this particular position, and if I draw a normal to a spherical surface, you all know this, when I draw a normal to the spherical surface, what is the idea? That normal should pass through the center of curvature, correct. So, the normal will be like this, correct. So, this would be the normal. So, if this is the normal, you all know that this angle here will be the angle of incidence. Now, let us consider a scenario where mu 2 is lesser than mu 1. So, this medium is having lesser refractive index than this medium. Let us consider a scenario like that. So, let us say mu 2 is lesser than mu 1. So, now under this assumption, can I say that this light ray which was actually traveling in this direction. So, it was traveling in this direction after entering into this medium, it bends away from normal, correct. So, this is the normal, this is the initial light rays direction. So, it moves away from normal. So, it bends like this. So, eventually we can say that this light ray travels like this, and let us consider that it meets somewhere over here. So, if I consider one more light ray like this, so we can say that this light ray, because it is passing through along the normal, so the normal at this surface will be along the same line. So, the angle of incidence for this light ray is 0. So, we can say that this light ray will just pass through and meet this light ray at this position, correct. So, that observer who is receiving the light rays will basically see that the light rays are converging at this point. So, this is where the image is formed according to him, clear. So, this is where the object is, this is where the center is, center of curvature of that interface is, and this is where the image is formed. That is where the refracted rays are converging with each other, and that is how we define image, correct. So, in this particular case, we can say that if this is the angle of incidence, if this is the refracted ray, the angle that this refracted ray makes with the normal will be angle of refraction. So, this is R, correct students. Okay. So, angle of incidence, angle of refraction. Okay. So, now in this particular scenario, let me write down few things here. We know that OP is the object distance, because in this case once again, because this is the pole, all distances should be measured from pole, clear. We can once again consider this as the principal axis, this line passing through pole and center of curvature is the principal axis, and all the distances either on this side or that side, all should be measured from pole. Okay. So, let us derive a formula for relation between object distance, which is this, and image distance, which is this. Just like we have mirror formula, which we have derived earlier, and plane surface refraction formula. So, this is spherical surface refraction formula, clear. So, let us do the derivation. So, what I will do is, I will assume that this angle is alpha, this angle is some beta, this angle is gamma. Okay. So, alpha, beta, gamma. So, that is R, this is gamma. Okay. Now, let us drop a perpendicular from here. So, let us call it as some P dash. It is very close to the pole, right. Now, one important thing which you have to keep in mind here is that all the derivation which we are doing is considering only the paraxial rays. So, we are considering only the paraxial rays. Now, you know that when paraxial rays are only considered, all these angles will be very small, correct. So, this light ray will be incident onto the interface at a very small angle, this angle will be very small, this angle will be very small. So, it basically looks like this. In reality, the diagram which I have drawn is just enlarged version for you to understand. In reality, it looks something like this. So, if this is where the object is, so the light ray will be striking the interface something like this, very close to the principal axis. The angle that it makes with the principal axis will be very small, clear. So, that is the actual scenario. Now, if you look at this particular scenario, can I say that alpha will be very small, and if I consider that center of curvature is somewhere over here, if I draw a normal passing through this, even beta will be very small, gamma will be very small, and even the angle of incidence will be very small. So, when I consider only paraxial rays, I can say that I, R, alpha, beta, gamma are very small angles, correct students, right. So, that is the idea of paraxial rays, clear. So, we can say this, and we can also say that this small gap which is formed here can also be neglected, because if you see here, if I drop a perpendicular from here onto this gap does not even appear to be there, right. So, if paraxial rays are considered, even PP dash can be considered to be 0. So, whatever distance we are calculating from pole can also be calculated from P dash. Okay. So, let me also write that P dash is equal to 0. Okay. So, these are the assumptions that I am going to take. Now, under these assumptions, let us derive the refraction formula. Okay. So, from the diagram you can see that in this diagram, so let us name some points here. Let us call this point as some A, right. So, if you look at triangle OAC, OAC, so which is this triangle, I can use interior opposite angles sum is equal to exterior angle. So, this is one angle alpha, this is one angle I. So, alpha plus I is beta, correct. This is the exterior angle for these two, correct students. So, alpha plus I is equal to beta. Let me write it down. So, alpha plus I is equal to beta, correct. Now, similarly, this time, okay, I will also write the triangle which I used. So, the triangle is OAC. So, triangle OAC. Now, similarly, if you look at the other triangle which is CAI, right, I can say this angle plus this angle should be equal to this angle, correct. So, this R which is formed over here with the normal, so this angle is the exterior angle for these two interior opposite angles, correct. So, in triangle, what is this triangle CAI? So, in triangle CAI we can say that beta plus gamma is R, correct. So, beta plus gamma is equal to R. Clear students? Now, if I apply Snell's law at this surface, because this is just normal refraction from first medium to second medium happening at this surface at this position. So, I can apply Snell's law. So, in this medium the angle of incidence is I, that is the angle that the incident light ray is making with the normal, and in this medium with the normal the refracted ray is making an angle of R. So, how do I write Snell's law? So, Snell's law. So, mu 1 into sine of angle in that medium. So, if I write it as mu 1 into sine I is equal to here mu 2 into sine R. So, mu 2 into sine R, right. Now, we know that if I apply the paraxial ray condition, so paraxial ray basically ensures that I and R are very small values, correct. Now, we know for very small values of theta, what can we say? We can say that sin theta is approximately equal to theta itself, correct. So, here what I can do is I can replace this sin I with I and sin R with R. So, I would be getting mu 1 into I is equal to mu 2 into R, correct. So, that is the idea. So, that is the expression which we get. So, we have two expressions which we have here. We got one expression from Snell's law. So, if I combine these three relations, let us see what we get. So, here I will be getting mu 1 into I. What is I from this equation? We can write I as beta minus alpha, correct. So, in place of I will write beta minus alpha is equal to mu 2 into R. So, mu 2 into R. What is R? R can be written as beta plus gamma. So, beta plus gamma, correct. So, that is the expression which we get. So, here we know what alpha, beta and gamma here represents, right. So, we know that because these angles are small, we can understand the value of sin theta as theta, and this can also be understood as tan theta. So, correct. So, I will be applying that result here. So, beta can be understood as tan beta, and you know how to write tan beta? Tan beta is this length by this length, right? Similarly, alpha can be written as tan alpha is this length by this length. Similarly, tan gamma is this by this, right? So, we will use that. So, thereby we can bring all the object distance, image distance into this expression. So, if I do that, so let me bring all betas to one side and the remaining values to the other side. So, I am getting what am I getting? So, mu 1 into minus mu 1 alpha, correct? If this beta goes to that side and gamma comes to this side, minus mu 2 into gamma, correct, is equal to beta into, I have mu 2 and there is one mu 1 coming from the other side. So, beta into mu 2 minus mu 1, correct. So, now I will substitute the values of the lengths, right. I will view all those angles as tan of those angles and I will substitute the values. So, first alpha, we know that tan alpha is basically this length. Let us consider this length as some h, which will eventually get cancelled out. So, h by this, correct. So, minus mu 1 into h by, what is this length? We know that this length is object distance, correct, but for now I will just substitute it as OP. We know OP is object length, object distance, but let me write it as OP itself. You will understand why. Minus mu 2 into gamma. What is gamma? Gamma is here. So, h by this. We know that this is the image and the distance from the pole is image distance, but let me write it as pi. So, h by pi is equal to beta into, okay, beta, what is the value of beta? Let me write the value of beta. So, beta means tan beta, right. So, beta is equal to h by this length. This length is r, from the center to the pole the distance is r. So, beta, which is tan beta, can be written as h by r, clear. So, I can write it as h by, I will write the length as Cp. So, Cp into mu 2 minus mu 1. Okay, so you might wonder, why can't I just write it as u, v and r? So, the reason why I have not written them like that is because when I write it like this, you know that these are magnitudes, clear. OP is magnitude, PI is magnitude, CP is magnitude, correct. So, what I am going to do is, I am going to now directly include the sign convention into this expression. So, please observe carefully, whatever expression which we derived here, the lengths are only magnitudes, these are just pure lengths, clear. These do not include any sign convention. So, if I have to include sign convention, first let me see how to apply sign convention. We know that light ray is travelling in this direction. So, this direction will be positive. Now, we know all the distances should be measured from pole. I will write it down here as well. All distances are measured from pole. So, let me substitute the sign convention. How do I take each and every value? So, if this is the image distance, so image distance is represented with V. So, how do I write V? So, is V here positive or negative? So, we know that the magnitude of V is Pi, correct? Magnitude of V is Pi, but is it positive or negative? Is it in the direction of the incident beam or opposite? When I see from the pole, it is in the direction of incident ray. That is the case which we have taken, correct? Which means the value of V here is plus Pi. So, that is the sign convention, correct? Similarly, next is object distance. Let us write object distance as u. So, u is equal to, now if you see from pole, object is on this side, which means opposite to the incident rays. So, in such a case, I should take object distance as negative, correct. So, u is negative of, what is the magnitude of object distance OP. So, OP. Clear, students? Now, similarly, CP is R, right. So, in this case we can say even the center of curvature is on this side, correct. So, whenever I am writing the value of R, so I should be writing it as minus of Cp. So, this length is Cp, and because it is on this side, because the center of curvature is on this side, so I should be considering the value of R as minus of Cp. Is that clear? See, it is similar to understanding the scenario where if I have a concave mirror, if the focus will be here, we consider that the focal length of concave mirror is negative, right. So, in the same manner, the radius of curvature of this interface is minus of this length. So, R should be taken as minus R for this scenario. Is that clear? So, this is the sign convention for this scenario. So, now let us apply the sign convention into that. So, if you see here OP is nothing but minus U, correct. So, if I substitute that, I would get mu 1, okay, H gets cancelled, I am not going to write H and H is getting cancelled. So, OP is minus U, so there is one minus in the numerator. So, this becomes, or let me write it, minus mu 1 by, in place of OP I will write minus U, clear, minus mu 2 by Pi. What is Pi? Pi is V itself. So, V is equal to, on the other side we have mu 2 minus mu 1. So, mu 2 minus mu 1 by Cp. What is Cp? Minus R, clear. So, minus R, clear, students. So, what I have done is these are just pure lengths, but by converting them into sign conventions, now whenever I need any other case, so if I have some other case in which let us say the curvature is like this, I can use this formula for solving that case also. So, I have applied sign convention to this scenario, so that I can use this expression for any case. Is that clear? So, this is the final expression which we have. Let us simplify this further. So, here minus and minus is getting cancelled. So, we have a minus sign over here. So, if I simplify this, if I multiply the whole thing with minus, this will go away, this will go away, I will get a new minus sign here, correct. So, the final expression would be mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. So, remember this is the general formula, clear, students. So, this is the general formula. So, you can use this for any case wherever the object is, whether the object is on this side, that side, curvature is on this side or that side, clear. For any case you can use this expression mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. Now, there is one important thing which you will have to keep in mind. I have told you this during plane surface refraction also. Sometimes it is better instead of remembering them as 2 1 2 1, it is better if you remember them as final medium and initial medium, because sometimes let us say if the object is placed here and if this is still called as mu 2, then what will you do? So, in such a case you should keep in mind that this expression basically means mu final by V minus mu initial by U is equal to mu final minus mu initial by R. So, it is better you remember it this way. Final in the sense, finally in what medium is the light ray entering, initial in the sense from which medium is the light ray originating. So, in this particular case light ray is starting here in this medium. So, this is the first medium, this is the initial medium and it is entering into this medium. So, this is the final medium. So, it is better you keep this in your mind, clear. Mu final by V minus mu initial by U is equal to mu final minus mu initial by R. So, that is the idea, students. Now, I want you to notice one thing here in the final result which I have derived. Think about what happens if r becomes infinity. What is going to happen? Can you think about that? If r becomes infinity, first let us see what happens to this expression, right. If r becomes infinity, this whole term becomes 0, right. This whole term becomes 0, and when this becomes 0, what do I get? Let me write it here. If r is equal to infinity, I am getting this is 0. When this is 0, if I send this to the other side, I would get mu final by V is equal to mu initial by U. Have you seen this expression anywhere? Yes, it is the expression which we derived for plane surface refraction. Why am I getting that now? Because r is equal to infinity means this surface is having a radius which is infinity. So, that basically means that this surface is becoming a plane. Plane is the surface which has a radius of infinity, radius of curvature of infinity. So, what this means is that the interface is a plane, and that is the reason why we got this particular expression. Clear, students? So, we can understand that. So, this is how we use the image, or how we find the image whenever we have a surface which is in the form of a spherical, which is in the form of a sphere separating two different media. Clear? So, we will see some applications of this. So, students, let us understand the application of that particular result which we have derived by taking an example, right. So, first I will write down the expression. So, it is mu final by V minus mu initial by U is equal to mu final minus mu initial by R. Now, keep in mind once again, whenever we are substituting the values for U or V or R, they should be substituted with sign convention. Remember, when I derived, I have substituted the sign convention for R also. So, whenever you are using this, you will have to apply sign convention while substituting radius also. So, this is one case where most of us will be making mistakes. Clear? You will substitute U correctly because you are used to doing that in mirrors and all that, but when it comes to R, you will directly put the magnitude. So, do not do that mistake. So, let us see some examples, you will understand the idea. Okay. So, let us consider that we have an interface separating air, and let us say this is glass. So, the surface, the interface is spherical, the radius of which is 5 centimeters. Clear? So, with glass, you know that the refractive index is 3/2, correct? Okay. Now, let us say there is an object which is here at a distance of 10 centimeters. Now, light rays which are coming from this object will undergo refraction at this surface and form an image somewhere. So, we need to find out where the image is formed. Clear? Okay. So, principal axis, pole. What I will do is I will first write the equation, the curved surface refraction formula, the spherical surface refraction formula. I will find where the image is formed, and based on that I will also draw the ray diagram to understand how the image is being formed. Clear? So, let us first apply. So, I would suggest whenever you are using this formula, before you substitute, first write the values of mu initial, mu final, U, R and all those, so that you get used to writing it correctly. Clear? So, light is travelling from here and entering into this medium. So, this is the initial medium and this is the final medium. So, I will first write the values down. So, mu final is 3/2, mu initial is, because it is air, it is 1, right, and similarly object, light rays are travelling in this direction, object is to the left side, which means from the pole to reach the object I have to go this way, which is opposite to the convention which we have taken. So, u is negative. How much is the value? Minus 10. So, I should substitute u as minus 10. Now, what about r? So, center of curvature is also on this side, right, because the curvature is like this. So, this sphere will have its center on this side, right. So, it is 5 centimeters. So, center of curvature will be somewhere over here, correct, and I should take that also as negative. So, yeah, I have all the values. Now, I will directly substitute that into the equation. So, mu final is 3 by 2. So, 3 by 2 divided by V minus mu initial is 1 by u. U should be substituted as minus 10, correct. So, this should be equal to mu final minus mu initial, final minus initial, 3 by 2 minus 1. So, I will write it 3 by 2 minus 1 divided by r is minus 5. So, that is it. So, if you are able to write these values correctly by looking at the diagram, rest is just simplification of that. So, nothing new. So, you can simplify this now. So, see what you are getting. So, I will be getting 3 by 2v is, sorry, this becomes plus 1 by 10 is equal to, I would have 3 by 2 minus 1 is 1 by 2, 1 by 2 divided by minus 5 is how much? Minus 1 by 10, correct. Now, simplifying this further, if I send this 1 by 10 to the other side, I would be getting 3 by 2v is equal to 1 by 10. If it goes minus 1 by 10, so it becomes minus 2 by 10. So, that is it, students. Simplifying this will be giving you v is equal to, how much is that? V will be 30 by 4, correct. So, 30 by 4 is 15 by 2, but there is a negative sign. So, minus 15 by 2 centimeters, which is 7.5 centimeters, minus 7.5 centimeters, clear? Okay. So, we found the image as minus 7.5. Let us locate it first. Where is minus 7.5? So, minus 7.5, will it be 7.5 to this side or 7.5 to this side? So, it will be 7.5 towards this side, clear, because negative sign implies that, right. So, what we can understand here is, if I draw a if I draw a normal here, so because this medium has a refractive index of 3 by 2, which is greater than that of air. So, this light ray, which was initially travelling along this direction, right. So, this light ray was initially travelling along this direction. After entering into this medium, will bend towards the normal, correct. So, instead of travelling along this line, it goes like this. So, it bends towards the normal. Do you understand that? So, please observe carefully. This was the direction of incident ray. So, this is our incident ray. After refraction, if refraction would not have occurred, it would have travelled along this ray. So, this dotted line which you have here, but because of refraction, because it is entering into denser medium, it is, instead of going like this, it is bending towards the normal. So, this is the normal. So, I hope you can see that. So, this is the normal, this was the incident ray's direction, and this is our refracted ray, clear. Now, if this is the direction of refracted ray, now you can understand where does it appear to come from. So, to understand that, I can extend this refracted ray backwards, and it appears to come from a point here. So, this is the object, this is the image, and this is the center. Clear, students? So, that is how we got minus 7.5. So, whenever you need to understand the ray diagram, first derive the answer, derive where the image is formed, and based on that you will get an idea of how and where the image is formed. Clear? Now, let me ask you one more part for the same question. So, let us write down the question as well. Locate the image and find its nature. Find its nature. So, you know what nature of image means, right? So, whether the image formed is a real image or a virtual image. So, what do you think? The image which is formed here, What do you think? Is it a real image or a virtual image? You can understand that by the ray diagram. So, if you look at this refracted ray which is travelling like this. So, this is the refracted ray, right. Now, is that refracted ray really coming from the image or it appears to come from the image? So, that is how we decide whether the image formed is real or virtual, right. So, in this case this light ray is not actually coming from here, correct, because you can understand that the other light ray is this one. So, this is the other light ray which just passes through. So, the person who is seeing from that medium is receiving this light ray and this light ray. So, what is he doing? He is just extending them backwards and thinking that it is coming from here. So, it basically means that this value which I got minus 7.5, this tells us that the image is virtual. Correct, students? So, that is the idea, right. So, let us see what would happen if I just change the curvature of this interface. We will solve the same question, clear. Let us consider that this is case 1. So, this is case 1. So, let us now solve case 2 in which this curvature instead of being like this, let us say it is like this, clear. So, let us see that, and in that case also let us understand where the image is formed and also the nature of image formed, clear. So, I will draw the diagram for that. Okay, let us draw a little bigger. Okay. So, this is the medium, let us say, right, and the object is over here. So, as I told you, first let us write the expression and find the image location, then we will draw the ray diagram. First, this is the incident ray. So, this is where the center of curvature would be, this is the object. So, normal would be like this. So, the reason I am asking you not to draw the ray diagram before itself is because, see, we know that this light ray will bend towards the normal, right. So, it bends towards the normal in this manner, correct. So, instead of travelling in this direction, we know it bends towards the normal. So, I am not sure how much it bends. Should I draw it till here or till here? I do not know how much it bends, clear. So, I can only understand how much it bends by looking at the final location of the image, right. Okay. So, let us see. So, once again if I write the values mu final, mu initial, u and r. So, let us write the values first. Mu final, what is mu final? Final medium is 3/2, initial medium is this 1, u is still the same minus 10 centimeters, right, same case as earlier, right. R, what is r now? We have taken radius of curvature as 5 centimeters. So, what is r in this case? Plus 5, because center will, center is not here, I have drawn it, okay, my mistake, very sorry, the center is not here, I was drawing the same normal for the earlier case. So, where is the center of curvature? So, this is where the interface is, right. So, center of curvature would be somewhere over here. So, center of curvature let us say is over here, okay. So, which means if I draw a normal, so the normal would be like this. So, keep in mind this is the direction of incident ray, correct, right. So, if this light ray bends towards the normal, so it could travel like this, it could travel like this, it could travel like this. So, I do not know which of these will the light ray take unless and until I know where the final image is formed, clear. So, that is why we are first going to derive the location of image. So, r, how much is the value of r? 5, right, because center is on this side itself, I will take it as plus 5 centimeters. So, let us substitute the values. So, mu final by v minus mu initial by u, which is minus 10, is equal to mu final minus mu initial which is 1 by 2 by r is 5, that is it. So, if I simplify this, I would get 3 by 2 by v or 3 by 2 v. So, 3 by 2 v, this is plus 1 by 10, if it goes to the other side it becomes minus 1 by 10. So, I would be getting, here we already have 1 by 10, and when this 1 by 10 goes to the other side it becomes minus 1 by 10, correct, and that is it. So, when I simplify this, 1 by 10 minus 1 by 10, we are getting 0, correct. So, what does that mean? So, when will this expression become 0? So, this expression will become 0 if v is equal to infinity, right. So, when v becomes infinity, that is when the value here will become 0. Is it really getting cancelled? This is 1 by 10 plus 1 by 10. So, if it goes to the other side, 0, right. So, we are getting that v is infinity. What does v is equal to infinity mean? When is v infinity? It will be infinity if the light rays are becoming parallel to the principal axis, correct. So, the light ray after refraction from here is travelling like this. So, the light ray is travelling in this manner, right. So, these would be the two light rays. One light ray will pass through and the other light ray will it will refract here and it becomes parallel to the principal axis. That is what is the result telling us. So, which means a person who is viewing it from here will think that the light rays are coming from infinite distance, clear. So, that is what it means, and remember, whenever image is being formed at infinity, we cannot comment on whether the image is real or virtual, because I have got this as infinity, but this could have been plus infinity or minus infinity, right. Both will give you the value as 0. So, we can consider that the light rays are either coming from negative infinity, or you can consider that the light rays are converging at plus infinity. Both mean the same in this case. So, that is why we cannot comment on the nature of the image in this particular scenario. So, please keep in mind, whenever image is formed at infinity, nature of image cannot be understood. Nature of image cannot be defined, right, students. Okay, we will see some more examples, a case, at least a case where something like this does not happen. So, we will see some more. So, students, let us understand few more. So, here you can understand this case, air, a medium of refractive index 2, curvature is 10 centimeters and the object is at 20 centimeters. So, let us quickly write down the values mu final, mu initial, u and r. So, mu final is this 2, light is travelling, it strikes the interface in this manner, right. So, center of curvature would be somewhere over here, let us say. So, if I draw a normal, so the normal would be like this would be the angle of incidence. Okay, anyways, so mu I, this is the initial medium 1, object distance is 20, right. Should I write 20 here or minus 20? It should be minus 20, because this is the direction of incident ray, object is on this side. So, minus 20 centimeters. What about r? Center of curvature is on that side, same direction as the incident rays. So, plus 10, and rest is just substituting, right. So, mu final by v, which is 2 by v, minus mu initial by u, which is 1 by u. What is u? Minus 20, is equal to mu final minus mu initial, which is 2 minus 1, which is 1, divided by r. R is plus 10. So, plus 10. So, that is it. So, simplifying this, I would be getting 2 by v is equal to 1 by 10. This is plus 1 by 20. When it goes to the other side, it becomes minus 1 by 20. Simplifying this will give me 1 by 20, and solving. So, 2 by v is equal to 1 by 20. So, I get v is equal to plus 40 centimeters. Now, what does plus 40 mean? Is it on this side or that side? plus indicates in the direction of incident ray, correct. So, which means this light ray after refraction is traveling something like this. So, it is bending towards the normal. You can see from the diagram that this is I and this is R. R is lesser. R is lesser means the light ray is bending towards the normal. This was the initial direction in which the light ray was traveling, and it is bending towards the normal and it is traveling like this, clear. And you can easily understand that the other light ray would be this, and which passes through in the normal incidence scenario and both meet here. Now, you can tell me whether this light ray, whether this situation where the image is formed, is it a real image or a virtual image? It is real, because this image is being formed by actual intersection of two light rays, clear. So, this is a real image. So, students, keep in mind, whenever you are dealing with image formation in the case of refraction, see, the idea is pretty simple. See, you know that incident rays are in this medium, correct. So, incident rays are in this medium, refracted rays are in this medium. So, these are the refracted rays. So, refracted rays are in this medium. Now, listen carefully. If image is formed in the region where refracted rays are present, which means if the image is formed in this region, it means that the image is being formed by actual intersection of refracted rays, because that is the region where refracted rays are present. So, the image is real, clear. If at all, if in the same scenario, if I would have gotten a negative value means image is formed here, but keep in mind, image is here, but refracted rays are in this medium. So, what does that mean? It means that the refracted rays are not actually intersecting, but when extended backwards, they appear to intersect here. Is that clear, everyone? So, what you will have to understand is, the idea is pretty simple. If the image is formed in the final medium, then the image is real. If the image is formed in the initial medium, then the image is virtual, as simple as that. So, final medium is where the refracted rays will be present. So, if image is formed there, it means that it is formed due to intersection of refracted rays. So, it would be real. So, if image is here, then the refracted rays are not actually converging, they are diverging, appearing to come from a point here. So, that is how you should understand whether the image is real or virtual in cases of refraction, clear. Okay. So, let us see one more example here. So, this is a case which involves both plane surface refraction as well as spherical surface refraction. So, you can see that here plane surface refraction, here spherical surface refraction. So, if the observer is on this side and looking at the object, so where will he see the object to be present, right? Okay. So, let us first write for the first surface. So, this is the first surface and this is the second surface. You know this, we have to write the equations successively, and the image formed by this will be the object for the second surface, correct. So, first surface. Okay, I can directly write mu final by V is equal to mu initial by U. So, mu final, let me directly write, I think you are all aware of that, right. So, mu final for this interface is 2. So, 2 by V or V dash, let me call it as, because this is an intermediate image, right. So, 2 by V dash is equal to, initial medium is 1. So, 1 by U, U is 10. Now, if I simplify this, I would be getting the value as V dash is equal to 20 centimeters. So, you know that object and image will be on the same side in the case of plane surface refraction. So, and I got the value of V dash as 20, which means the light ray appears to come from here after refraction. So, if I draw the light ray, so let us say this is the incident ray and the normal would be like this, horizontal, you know that, because the surface is plane, this is the normal to that. So, this light ray after refraction at this plane surface, let me draw that correctly. So, after refraction from this surface will slightly bend towards the normal, correct. Instead of traveling like this, it bends towards the normal, and where does it appear to come from? It appears to come from over here. So, that is the idea. So, this light ray which is now going to strike the second surface, where is it coming from according to this surface? It is coming from here, right. So, this is let us say I dash, intermediate image. So, this intermediate image formed in the first surface will be the object for second surface, correct. And remember, this 20 centimeters which we got is distance from here, right. So, this length is 20 centimeters. Now, let us write for second surface. Remember, second surface is spherical surface refraction. So, I told you for writing spherical surface refraction, start with mu final, mu initial, u and r. We can substitute later. Mu final, what is the final medium into which the light ray enters? Air, 1. What is the initial medium in which the light ray is striking? 2. So, 2. What is u? For this object, where are the light rays coming from? Light rays are coming from a point here, and this point is at how much distance? 20 plus 20, 40, correct. Should I take it as plus 40 or minus 40? Minus 40, right, because light rays are travelling like this, object is on this side. So, minus 40 centimeters. What about r? You can clearly see that the curvature is like this, which means center would be somewhere over here or here. So, center would be somewhere over here. Incident direction, center is on this side. So, negative. So, minus 10. So, that is it, students. So, all you will have to do now is substitute these to find the image location. So, let us do that. Mu final by V, right, minus mu initial by u, u is minus 40, is equal to mu final minus mu initial by r. Mu final minus mu initial, which is 1 minus 2, which is minus 1 by r. R is minus 10. So, that is it. So, what do you get by simplifying this? 1 by V is equal to, here we have 1 by 10. What do we have here? 1 by 20 with a positive sign, right. If it goes to that side, it becomes negative. So, minus 1 by 20. So, what do we get solving this? 1 by 10 minus 1 by 20 will be 1 by 20. So, which means the final answer which I will get is V is equal to plus 20 centimeters. Now, you can easily understand, you can draw the ray diagram as well. So, this light ray will strike here, this would be the normal there. But remember, it is entering from denser into rarer, correct. It is entering from denser into rarer. So, from the normal it bends away. So, it should have travelled like this, but it bends away from normal, and it bends away from normal, and by looking at this you can easily say that it converges somewhere over here at a distance of 20 centimeters. Clear, students? So, this would be the path followed by light ray. So, here it travels like this, it travels like this, it bends towards the normal, appears to come from here. So, this light ray strikes the second surface, and here it refracts. Instead of travelling like this, it bends away from normal and eventually meets the principal axis at this position, and that is where you can consider the other light ray, which is the normal light ray. That is where the second light ray also reaches, and that is where the final image will be formed. Now, you can easily tell whether the image formed is a real image or a virtual image. What is it? You can clearly see from the diagram, the image is formed by actual convergence of two rays. So, the image formed will be a real image, or like I told you, by looking at positive sign, you can say that the image is formed in the same medium in which the refracted rays are present. The refracted rays are these, the final refracted rays are these, this one and this one. So, the image is being formed in the same medium where the rays are present, where the refracted rays are present, which means the image is formed by actual intersection of those light rays. So, real image. Clear? So, we will see few more. Students, let us see one more example. So, here they have given us a glass sphere. So, refractive index is 3/2 and 3 points are mentioned. C is the center, A and B are 2 points which are at distances of 5 centimeters from center. So, radius of curvature of this sphere is 10 centimeters. So, that is the information given to us. Okay. So, they are saying that we are given 3 cases. In case 1, object is placed at C, case 2 at A, case 3 at B, right, and we need to find out the location of image, right. So, let us do this. I will first solve for case 1, okay. I will write the values mu final, mu initial. So, mu final, mu initial, then U and R. So, now the object is here. So, the light rays are travelling like this, correct. So, this is the interface. So, man is observing from here. So, light rays should travel this way. Okay. Final medium is air. So, 1 initial medium in which the light rays are going to travel is 3/2. Object distance from the interface is R, which is 10 centimeters, but if it is on this side, we should take it as minus 10 centimeters. Now, what about R? R is also on this side, C is also the R, clear. So, it is also on this side. So, I should substitute this as minus 10 centimeters once again. Okay. Let us substitute this in the formula. Mu final by V minus mu initial by U. U is how much? Minus 10 is equal to mu final minus mu initial by R. Mu final minus mu initial is minus 1/2 by R. What is R? R is minus 10, correct. Okay. So, simplifying this, I would be getting 1 by V, minus minus gets cancelled. I will get this as 3/20 is equal to minus minus gets cancelled. I will get 1/20. Okay. So, simplifying this, if I take this 3/20 to the other side, 1 minus 3/20. So, I get 1 by V is equal to minus 2/20, implies V is equal to minus 10 centimeters. So, what does minus 10 mean? Minus means that the image is formed on this side, correct. Light rays are travelling this way. Let me draw another diagram for case 1. So, this is where the center is. So, this is the interface, correct. So, light ray, if I consider one particular light ray which is incident in this manner. So, we got the image to be present at minus 10. So, what does that mean? This is minus 10 once again. So, object distance is minus 10, image distance is minus 10, which means we got the answer as object and image are coinciding with each other. Now, why is it happening that way? You can easily understand, because the light ray which is incident, because it is coming from the center, can I say that this line will also be the normal, which means all the light rays coming from the object are along the normal. So, it basically means that the light rays without undergoing any refraction or without any bending will just pass through. All the light rays, you can consider any light ray which is coming from the object, each and every one of those light rays will be along the normal, because object is at the center, correct. So, that is the idea. So, in every light ray will be appearing to come from the center. So, each and every light ray will pass through undeviated. So, a person who is viewing from here will see that the light rays are actually coming from the same point. So, that is why we got object distance and image distance and object distance to be same, right. So, let us do for case 2 now. So, case 2, I think you can easily say that the only thing that varies in case 2 for when object is placed at this position, let me draw the diagram. So, this is center, the object is here. So, mu f, mu I and R remains the same. So, I can directly say that the value of u is the only thing that changes, and this would be 15, right. 10 This whole thing is 10 plus 5. So, I will substitute the values. So, mu final is 1 by V minus mu initial is 3 by 2 by u is minus 15. So, minus 15, right, is equal to mu 2 minus mu 1. I mean mu final minus mu initial, 1 minus 3 by 2, which is minus 1 by 2 by r. What is r? Minus 10. So, that is it. So, we will have to simplify this scenario. What do we get? 1 by v. So, 3 1s and 3 5s. So, minus and minus gets cancelled, I will get plus. So, 1 by 10 is equal to minus and minus gets cancelled, 1 by 2 by 10, which is 1 by 20, correct. So, simplifying this, I would get 1 by v is equal to 1 by 20 minus 1 by 10, which is minus 1 by 20, implies v is equal to minus 20 centimeters. So, you understand what that means. So, object is actually here, this is the center, right. So, if I draw the ray diagram to understand this, so if a light ray is incident in this manner, so this will be the normal. You know that after passing through, after refracting, it is entering a rarer medium, right. So, instead of travelling in its own direction, which is this, what will happen? Because it is entering into rarer, it is bending away from normal, right. So, instead of travelling along this line, it is now travelling like this, or maybe not this much, like this, in such a way that it appears to come from a point which is at 20 centimeters from the interface. So, from here 20 means this. So, this light ray appears to come from here. So, that is how you should understand, clear. So, I would suggest you solve for case 3. So, when the object is here, write a similar equation and find out where the image is formed. You can easily say that the image which is formed here, this one is a virtual image. So, similarly, I would want you to do for case 3, right, when the object is placed at B, right. So, students, this topic basically has very few concepts. So, we will be solving mostly different types of questions only. So, we will see one more question. This time let us consider successive refraction from curved surfaces, clear. So, let us take a scenario like this, where we have a sphere, a solid sphere made of glass, you can say. So, mu is 3 by 2. Clear. Instead of keeping the surrounding medium as air, you can also immerse this whole thing in water as well. But let us first solve for air medium, clear. So, this is air, this is air, clear. An observer is on this side and there is an object over here. So, let us say the radius of this is 10 centimeters and the object is at a distance of 20 centimeters. Okay. So, now you know that the light ray which is going to travel should first refract from this surface, right, form an image that will act as an object for the second surface. The light ray will once again refract from the second surface and then eventually reach the person's eye, right. So, if I take the incident ray like this, so you know that the center is here, which means normal is like this. So, as I told you, let us not draw the ray diagram immediately, let us derive the values and then based on that we will draw the ray diagram. So, first surface, so here I will write for first surface. So, let us substitute, let us write down the values first. Final is 3 by 2, so mu final is 3 by 2, mu initial is this medium 1 and radius of curvature. This is the interface, center is on that side, light rays are also on travelling that side. So, positive R, and how much is the value of R? Plus 10. Then U, what is U? Object is here, interface, incident rays direction, but object is on the other side. So, minus 20. Okay. Now, let us substitute the values. Mu final is 3 by 2 by V minus mu initial is 1 by U, U is minus 20 is equal to mu final minus mu initial, which is 1 by 2 divided by R, R is plus 10. So, that is it. So, when I simplify this, I would be getting the value as 3 by 2V plus 1 by 20 is equal to 1 by 20, right. So, they are cancelling out. So, which means I am getting 3 by 2V is 0. You know what that means? 3 by 2V is 0 will imply V is infinity, right. So, when will the light ray or when will the image be formed at infinity? If this light ray becomes parallel, correct. So, that is how the light ray would travel, clear. And now we can solve for the second interface. So, this is the value. So, now this light ray is traveling parallel to the interface. So, when I write the equation for the second interface, what is the object distance for the refraction at second interface? The light ray is coming from where? So, this is one light ray which is traveling through like this. Now, where is this light ray and this light ray going to meet? They appear to meet at infinity. So, what is the object distance for the second surface? Infinity. So, let us write the expression for second surface. So, second surface. Okay. So, if I write the values, mu final medium is air, initial medium is 3 by 2, mu initial is 3 by 2, u is infinity. You do not have to worry about whether it is plus infinity or minus infinity, whatever it is, when divided it gives you 0. Okay. R, what is R? What is R value for this surface? Is it positive or negative? Center is here, light rays are this way, center is on the other side. So, negative, and the value would be 10, correct. So, 10 centimeters, but on the other side, so minus 10 centimeters. So, that is it, students. So, just substitute the values now. Mu final is 1 by V minus mu initial is 3 by 2 by u is infinity, is equal to mu final minus mu initial, which is 1 minus 3 by 2 minus 1 by 2 by R is minus 10. So, that is it. So, simplifying this will give me, this whole thing becomes 0, right. So, I would get 1 by V is equal to minus and minus gets cancelled, and I will get 20, 1 by 20, which means V is plus 20 centimeters, clear. So, plus 20 from this interface, plus 20 means what? In the direction of light ray, correct. So, light image is finally formed on this side itself, and we can say that it will be formed at a distance of 20 centimeters, right. So, which means this light ray will converge over here, and image is formed like this. So, it would be symmetrical basically. So, this is 20, this is 20, this is also 20 basically. So, that is the idea, students, because the light ray has become parallel here. So, we should consider the object distance as infinity and write the equation for second surface, right. So, that is the idea. So, I would want you to I will give you one more question, which you have to solve as your homework. So, solve the same question, same values, but considering that the surrounding medium is not air, right. So, consider that the surrounding medium has a refractive index of 4 by 3, water. So, the question for you, the work for you, solve by considering surrounding medium to have mu of 4 by 3. Clear? So, this whole glass sphere is immersed in water and all this is happening in water. So, solve this. So, idea is the same. First surface image will act as the object for the second surface. Once again find the image and that is it. So, that is it students for today. So, tomorrow's class will continue from where we left. So, we have few small concepts which we need to discuss like velocity of the image and magnification of the image. So, once these two topics are done, so curved surface refraction will be over, right, and then we can start lens.